So Jane asked me to chair this expert team meeting today as we have the day of today as all the others from UK due to the coronation, King's coronation.
Okay.
So today we continue the deep dive series to WIS 2.0 different components, and today we have a Global Discovery Catalogue, and Tom is here to tell us all about it. So without further ado, Tom, you're welcome.
Great. Thank you. Thank you, Mikko. I will just share up my screen. Let me see. Screen one. Okay.
And one more thing before you start, this meeting is being recorded, just to let everyone know.
Okay. Is everybody able to see my screen?
Yeah.
Okay, great. Okay, so I'm on a single screen, so I won't be able to see any comments or visuals. So if you do have any questions, feel free to bring them up. Thank you for letting me provide this presentation to your group. I don't know too much about your activity other than some discussions I've had with Jane and Jeremy and maybe some others. But I'll talk today about the WMO WIS2 project with regards to cataloging and metadata, particularly discovery metadata and the Global Discovery Catalogue. So I'm Tom Kralidis. I'm with the Meteorological Service of Canada, and I chair the WMO expert team on metadata, as well as the technical lead, the architect of the WIS2 box project, which you may have heard of. It's a reference implementation for data providers in WIS2. Oops. So today I'll walk you through a few different parts of the metadata and discovery story. One, I will touch upon the actual specification for core metadata in WIS2, or discovery metadata as we call it. The other one is topic hierarchy and classification and how that relates to data being published on WIS2. Then I'll walk into the meat of the discussion with the Global Discovery Catalog, what its role is, how it's supposed to work, as well as the implementation here in Canada. And then we can have a discussion. Happy to take any questions or comments thereafter. So here's a C4 diagram, or a high-level view of the container architecture for WIS2. So when I say container, I don't mean Docker. I do not mean Docker container. I mean container in the context of C4. So if you're familiar with C4, it's a way of doing designing software architecture and doing diagramming. So this is a C4 container diagram of all the different parts. So you can see the discovery catalog is in the middle of the core services diagram. The basic way the system works is that data producers, who are on the lower left, provide their data through a WIS2 node. The WIS2 node signs up to our global broker. Our global broker then subscribes to a WIS2 node. There will be hundreds of WIS2 nodes. And from there, the global broker is again subscribed to the WIS2 node. The catalog in the middle is listening to the broker, and then downloads metadata from the global broker as a result of publishing from the WIS2 node. So one thing I want to make clear here, if anybody's familiar with catalogs or metadata, we've traditionally done metadata exchange and synchronization through harvesting in the greater community. This is harvesting through APIs. So this is a different harvesting approach where we treat metadata in the same way as data. So metadata is published via via PubSub, event-driven, and in this case MQTT, which is a required specification for PubSub in WIS2. So as users submit and publish metadata through their WIS2 node, the broker obviously receives notification of that, relays that notification. The discovery catalog is listening to the broker, and it will then pull the metadata from the global cache, because the broker saves a copy of the metadata to the global cache. And then from here, the discovery catalog will ingest it and validate it. So I'll get into that a little bit later. After that, the discovery catalog does what you think it does in terms of providing an API to a search API to users. So WIS2 is heavily based on standards which enable interoperability. In terms of the Global Discovery Catalog, in terms of standards, we support the OGC API record standard, Part 1 core, which includes Open API, obviously, and this is available through Secure HTTP, so not too much of a surprise. The actual content or metadata encoding is based on something called the WMO Core Metadata Profile version 2, as well as some other companion specifications. Let's talk a little bit about WMO Core Metadata Profile version 2, or WCMP 2. So this is a discovery metadata model for data sets in WIS2. And this is different than, I just want to make the clarification that this is not station metadata, so we're not describing a station here, or a single observation for that matter. This is metadata around the data set. So, for example, if you have 200 automated weather stations in your region or in your country, you would have a WIS2 metadata record that describes the data that comes from those 200 stations. That's your data set metadata or discovery metadata. It can link the station metadata and the observation metadata just the same, but I just wanted to make clear what kind of metadata we're talking about here that facilitates the high-level search. And WCMP2 metadata can be seen throughout throughout many parts of the system. So as you can see here, everywhere that is circled in red, you can see that that's where the WCMP2 standard is implicated. Where did WCMP2 come from? In WIS1, we had WCMP, or WCMP1, let's say, and that's a bit of the historical lineage for WCMP proper. A few years ago, we did a number of WIS2 demonstration projects. One of them was a demonstration project around search and metadata, where we analyzed standards, architecture, and requirements, and we came up with a decision that that OGC API records and WCMP2 would be the way forward. So WCMP2 is a standard from WMO, which is being currently developed. It's very close to being, I would say, solid, or at least a 1.0. And it describes any metadata, whether you have metadata about a data set or a station, or sorry, a data set or a service or a process for that matter. So it's a very simple metadata standard where it encapsulates things like identifying a data set or a citation, extents, so spatial extents, temporal extents, very clear wording on and descriptions on data policy, that's the WMO data policy, as well as distribution or actionable links. And that's very important for helping tie things together to get the user from discovering the existence of a data set to actually downloading it or subscribing to it. You probably won't be surprised to hear that it is extensible, and it allows for additional properties as required. So the core metadata profile is what is required for compliance. And having said that, that does not stop any data producer from adding additional metadata elements to WCMP2, and which will not break compliance. Here's a high-level diagram of various sample metadata workflows where we would have, let's say, for an NWP model, we would have products by model run. We would have their discovery metadata by weather data variable and level type, and then that goes into to an API. The same thing for observing stations. We have our network of stations, let's say, as a data set, and then we have product types, and then that is made available through a catalog API. Just the same. But the one delineation that I wanted to make here is we clearly separate discovery and search of metadata from the actual data API or data services that a data provider puts forth. So what does that mean? That means, for example, if you have an NWP data set, the discovery metadata for an NWP data set, let's say by a weather variable, or if you want to document the entire model, is very high level. When you have a new model run, you would have metadata associated with that model run, and here are all the time steps and so on. That is not part of the discovery metadata or catalog API story. That would happen at the data level, whichever way you want to make that information available. So I just wanted to make that delineation, is that the metadata records for WCMP2 are a high level data set level metadata. The actual representation of WCMP2 is a hard break or a departure from the previous WCMP1, which was based on ISO 19115/19139. WCMP2 is rooted in the W3C spatial data on the web best practices, which includes the W3C data on the web best practices, as well as implementing the OGC API record standard, which includes support for RFC 7946 or GeoJSON for that matter. So a WCMP2 record from an encoding perspective is a GeoJSON. And it allows for, obviously, for extensibility. I'll give a few quick examples of various parts of the discovery metadata, WCMP2. So here we can have very simple title and description or abstract of a data set, and this is what it may look like in a WCMP2 representation. We have an idea of themes and concepts. So these are the controlled vocabularies or keywords that are associated with a data set, and you can have one-to-many of these. So basically, sets of keywords that adhere to a controlled vocabulary, and that's how this can help us further classify our data sets in WIS2. We also have a topic hierarchy concept, which is still in discussion in terms of implementation. But the idea here is to be able to classify the data, additionally classify the data. Spatial temporal extents, this is what they would look like. So if any of you are familiar with GeoJSON, the geometry on the right would probably look very familiar in terms of the way it's structured. We also represent time in a specific way, so either an interval or a timestamp for a single point in time. We also support a resolution parameter for, let's say, if you have hourly surface weather observations. We also support persistent identifiers. So maybe for research data, you have DOIs for specific data sets from a principal investigator. So we do have an external ID mechanism which allows you to link to a DOI or other type of mechanism for persistent identifiers, and these are one-to-many. You can have as many as you wish. Here's some examples here based on DOI and ARC and so on. We have the concept of providers or contacts, obviously. So you can have one-to-many contacts, and each contact can have one-to-many roles. So this means if you have a provider who serves the same role. So let's say you have a provider who's not only the point of contact, but they are also the distributor. You would be able to describe them both in this object. And you would have, in this case, we would have had roles with point of contact as well as distributor. So we allow that kind of capability, and that helps data producers identify who to contact and who the maybe the principal investigator is, and so on. Data policy, I mean, this is very important in the WMO WIS2 space. So in data policy, we would have either or core or recommended, which are the two values that are allowed in WMO with regards to the unified data policy. If the data is recommended, there's some additional information that can be provided in terms of licensing and other information. Having said this, this actual structure is in discussion, and we're actually coming up with a cleaner way to accomplish the same result, which would be a lot easier from a standards perspective. But all that to say is that with every WCMP2 record will have a data policy element. It clearly identifies it as core or recommended, and it will also clearly add links for and information for licensing and copyrights as required. Distribution. So I mentioned actionable links previously. So a WCMP2 record can have one-to-many links, and the links will all have very specific relation types. So you see the rel on the first line of this example. So those relation types are what are designed to help clients detect what kind of link they're dealing with, and be able to jump off and go to that link with relatively little a priori knowledge to be able to interact with it. The other aspect that we're discussing here is that we provide support for links for any protocol, and as well as APIs. And APIs may have parameters. So we have a way to encode a link and then provide descriptions around parameters and URI templates to APIs and so on. In this case, this is a data distribution link, which points to an MQTT server with a specific channel or topic. And from here, a WCMP2 search would result in a record which maybe has this link as part of a document. From here, a client can take that MQTT link, open a connection, and then do a subscription to be able to get real-time updates. Here's some examples on how we can document an API. So the above example is providing a link for an entire collection of an API. If folks are familiar with the OGC API efforts, this is an example based on OGC API features. Or we can document and provide a link to the entire API, regardless of a specific collection. So both are possible. If you have your data in an archive, for example, as part of the data set, either a zip file, or if you want to take it to the user to an HTML page, and maybe they have to sign up for something, I don't know. Those are both obviously supported. So the key thing here is that the link object is a very well-known pattern in WCMP2 and OGC. So any OGC API standard, for example, uses this approach, and this will give us the broad interoperability that we need for WIS2. If you have links which maybe have access control or security constraints, here you can document that a little bit more by adding a security object to your link, describing the protocol, the scheme, as well as maybe description on who to contact and so on. I mentioned previously that WCMP2 is extensible. So because it's GeoJSON as the encoding, and JSON and JSON schema for that matter allow for additional properties by default. I mean, this is obviously allowed in WCMP2. So you can add any number of elements that you wish underneath and over and above WCMP2 without breaking compliance. Here's an example of how you can do that. So you can see the underscore comment object is not part of WCMP2, or the approval status element is not part of WCMP2, but it's not, that doesn't break compliance. A WCMP2 validator will ignore those elements, but it will still pass as long as the required parts of WCMP2 are there. With that, I mean, that's a high-level view of the specification. The specification will also have code lists or controlled vocabularies. So those are key for the themes and concepts, or the keywords. And we also have the key performance indicators. So while you can have a WCMP2 record which is compliant, we will also have KPIs to be able to score your metadata and provide a ranking and provide suggestions on how to improve it. So the whole idea is continuous improvement of the discovery metadata in as much of an automated way as possible. And we are developing these KPIs and code lists in parallel to WCMP2. So we're writing the implementations as we write the specification. So that gives us a nice sort of agile way to validate the specification in real time. I'll send this presentation out after the call, but here's some initial examples for WCMP2 from that link. Topic hierarchy. This is another core concept, which is across a number of different parts of WIS2. So this is the heartbeat of WIS2, which allows you to classify and subscribe to a specific topic or channel, and be able to do filtering, for example. So a user or a data publisher in WCMP2 would publish in this publish a data set with a link with this kind of pattern. I showed something similar previously, but this is the basic idea, where you have a broker, and then that channel property there implements the WIS2 topic hierarchy, which is very structured, at least for the first 8 levels or so. And this will allow the user to subscribe to exactly what they need. Another place where we support the topic hierarchy is with the WIS2 notification messages. I don't want to talk too much about the notification message standard because it's not part of the discovery catalog per se. But for PubSub in WIS2, the message payload is based on GeoJSON, which is then this WIS2 notification message. And here's some examples on how that ends up being implemented in the notification message. Here's a workflow of the topic hierarchy, so you can search the discovery catalog on a specific topic, and then you can subscribe thereafter. I should note that MQTT also provides the ability to do wildcards in terms of subscriptions, and you can subscribe to broker services using these kinds of notations. And you can also put this in your WCMP2 metadata if you wanted to add a link for a user to pre-filter the data for the user with these wildcards. Here are the primary topic levels of the WIS2 topic hierarchy. The first 8 levels are defined by WMO per se, the core WIS team. The first 3 are infrastructure level. The next 5 are topical. So you see things like country, center ID, which is the name of the data producer, let's say, resource type, and data policy core are recommended again, and your system discipline. Level 9 and below are governed by domain communities. So that means within every domain community, hydro, cryo, weather, NWP, atmosphere composition, and so on, there is a community that's coming up with this part of the topic hierarchy underneath. And that allows the very core things to stay core, and that allows for the domain communities, who are the experts in the data, obviously, to properly classify and properly add these subcategories. And these end up being, all of these end up being part of the WIS2 topic hierarchy, which is key to the way data is discovered, and accessed, and exchanged. The WIS2 Global Discovery Catalog itself. So the catalog hits a number of different pieces of WIS2 just the same. So you can see the catalog is basically ingesting metadata from a WIS2 node, and then it is making that metadata, the WCMP2 metadata, available through an API. And the API can be used by whoever has access to it, whether you're a meteorologist or scientist or a subject matter expert, or a search engine, and or any other type of user or decision support system. I should note that the Discovery Catalog itself is open, and there's no secure access or authentication or authorization needed for using the Discovery Catalog API. So what else does the Discovery Catalog do? Again, it provides this cataloging discovery. It harvests WIS2 discovery metadata from WIS2 nodes. It provides this yellow pages approach that allows people to discover the existence of a data set and then further interact with it. It supports sort of indexing or crawling from mass market search engines, and it also implements the key performance indicators that we're working on in WCMP2. The basic way that will work is that we will be ingesting metadata into the catalog, validating it, and running key performance indicators on it in support of continuous improvement. So background on OGC APIs in general, we went with OGC API records as the API for the discovery catalog, and again, that's rooted in some recent activity from OGC to modernize all of their API standards, including the standard for discovery. So this is a bit of a background on what OGC's been up to, and we're following that on the discovery side via the OGC API record specification. So for those of you who may be familiar with search standards or discovery standards from in the community, you may be familiar with the OGC catalog service for the web specification, which was a first generation standard based on basically XML over RPC, and so on. So we're clean. The OGC has clean broken from that, and they're moving toward OGC API records, which is this modernized approach to doing a RESTful API for metadata. We have a core record model or a building block, which is this GeoJSON dialect, and I walked you through some of the core elements in WCMP2, which implements the OGC API records core model. I should make clear that WCMP2 only adds one additional element to the OGC API records model. The other thing that it does is various things that are optional in the OGC API records model, WCMP2 makes mandatory. So in that sense, it's a profile, and it does extensions and constraints on the OGC API records core model. Records itself, the specification, allows for either a static catalog or an API-based catalog. We're obviously doing the API-based catalog for the WMO Global Discovery Catalog. It also supports transactions. We have transactions disabled in our Discovery Catalog in Canada because we are following the WIS2 architecture, which prescribes the pub/sub approach for ingesting metadata. Here are some sample sort of query parameters or queries that you can run on the Global Discovery Catalog. So you can do spatial queries, which is sort of a minimum bounding rectangle or a bounding box. You can do temporal queries on metadata. So that can be either an instant in time or a time interval. So T1 and T2. You can also do open-ended temporal queries where you can say start from this date up until current. You can do attribute type queries, so title equals or any other attribute, which would then satisfy attribute type queries if you're searching on titles or keywords or other values. You can also do free text searches, so Q equals. This is very similar to sort of a search engine, mass market search engine type of capability. You can do sorting and paging and filtering the results for getting back smaller payloads of metadata as well. So very, I would say, simple and familiar query parameters that one might see in a search API out there. but based on an OGC standard. So I've walked through WCMP2, the Discovery Metadata Standard that we're using in WIS2. I've talked a bit about the topic hierarchy and how it sort of glues everything together. I've walked through the catalog API itself and which API we're actually going with to be able to search and discover the WCMP2 metadata. Now I'll talk a little bit about implementation. The implementation itself, before I move forward, in Canada we are running a Global Discovery Catalogue as part of WIS2. That's our core commitment, and we've implemented that in our mission critical infrastructure. So I'll talk a bit about that, and I'll dive a little deeper into how that's all put together. So the catalog the global catalog implementation itself, this is sort of a component diagram now of a global discovery catalog. So we dive a little bit deeper in the C4 context, and you can see here's our global cache, here's our global broker, and here's the node from which the catalog would harvest metadata from. So now let's go through this diagram in a bit of detail. The box with the dashes is the Global Discovery Catalog, the entire component, the entire container for that matter. What happens is when the Global Discovery Catalog is instantiated, it automatically subscribes to the global broker. And it's a long-running connection, and it's subscribed to the global broker for filtering only on discovery metadata, a discovery metadata topic. So metadata is a topic in WIS2, and it's available on the global broker. So in the GDC, we subscribe to the global broker, and we say, provide me notifications with only that only pertain to discovery metadata. So what happens is the following: the WIS2 node would provides the global broker subscribes to the WIS2 node. The WIS2 node generates discovery metadata for a data set. It sends a notification to the global broker for that discovery metadata. The global broker republishes that message for the discovery metadata. The WIS2 Global Discovery Catalog, who is subscribed to the global broker already, receives that notification. That triggers a registration workflow. So once we get a notification of new discovery metadata or updated discovery metadata in the global broker, we receive a message, and in that message, we parse the message, and the message itself that's coming from the global broker and the WIS2 node through the global broker has a link to where the actual discovery metadata is. So the global broker itself is subscribed to the WIS2 node, receives the message, relays the message, and actually saves the discovery metadata to the global cache. The catalog subscribes to the broker, gets the message, sends it to a registration workflow. The registration workflow pulls the discovery metadata from the cache, and it knows where the link is because it received it from the message. So it pulls down the discovery metadata record. From here, it will parse it, validate it as per the WCMP2 compliance testing. So it'll pull it down from the cache. It will validate it. If the validation fails, it will the catalog itself will reject the metadata. If the validation passes, then the catalog will ingest and store the discovery metadata into the backend, into the metadata backend, for example. And then it will also additionally run these key performance indicators to be able to provide additional feedback on the content. And it'll do things like, so the KPIs basically check if you have how is your title formatted? Do you have too many acronyms? Is your title too short? Is your title too long? All those kinds of value-added checks to the KPI. So it'll run, again, it'll run the compliance, it'll run the KPIs, stores the metadata into a backend, and then from that point forward, the backend is made available to the catalog API, which implements the OGC API record standard. And from here, any catalog client can interact with the API accordingly. Tooling. So this is a high-level architecture of the Global Discovery Catalog. This has been implemented in Canada. Our implementation in Canada is using some very specific tools. I have links to all of them later on in this presentation, which I will circulate. So we use something called WIS PubSub, which is a subscriber that we built, a subscriber tool that we built as part of the WIS2 box project. This is a Python implementation. So we use this tool, WIS PubSub, to subscribe to the global broker and filter messages. For registrar, we have a number of different Python tools that we use to do the validation, to do the key performance indicators, and working with the metadata itself. The backend itself, I mean, this is our specific implementation in Canada, but we use Elasticsearch as our metadata backend. In theory, this could be any metadata backend. You can have a Postgres database or Solr or whatever is applicable for your requirements. The catalog API itself is realized using the PyGeo API tool. That is an OGC API reference implementation. Again, those are only specific technology choices for the Canadian implementation. The reference implementation of a Global Discovery Catalog is also made. We've also made that available, which implements all these tools. The search then allows anybody to look for the existence of data sets. Here's an example of using the Global Discovery Catalog with QGIS, which is a free and open source desktop GIS tool, which has a search interface. And we basically connect QGIS here to the Global Discovery Catalog. And we can see how things work. So you can see the search interface, the results. You can probably see some footprints on the main map for metadata results. QGIS is a generic GIS tool. It doesn't know anything about WIS2. It doesn't know anything about WMO. But because we're using these core standards, which give us broad interoperability, we're able to use these tools off the shelf. Another tool that we'll be able to use off the shelf is obviously the web browser, because we're doing things in a very structured way in the catalog and the representation in the catalog with regards to linked data and so on. So the actual Discovery Catalog is stood up. There are not very many metadata documents there because we are working with various data providers, being in the pilot phase of the WIS2 project. So, but they are showing up. There are some 60 or 70 metadata records from Canada currently, and those can be made available. Those can be visualized from this URL, and you're able to search and get back results and see and review the various results. Here's a search result, for example, for real-time surface weather observations from Canada. And this is what it would look like from a machine-to-machine interface, which is basically the WCMP2. Our Global Discovery Catalog, in supporting OGC API records, we do have an open API or a Swagger endpoint, which would allow power users or developers to interact with the API and kick the tires, if you will, to learn more about the API and maybe use these URLs in their own application. Here are some implementations and tools for not only the Global Discovery Catalog, but the various metadata standards that the WCMP2 that I described and the tools around it, such as PyWCMP, which does validation, and it does the KPI quality assessment, and so on. And then we have some servers and clients as an addition. So, okay, I'm going to skip over that one. Here are some links. One link that I did not include, which I will include in this presentation, when I send out the email is the Global Discovery Catalog reference implementation, which is here. So this is what we're using in Canada, and we're publishing it to GitHub. It's free and open source. And this basically implements the architecture which we just described. So this is a Python tool, you would install it, and you would set it up, and then you would start a long-running connection to the broker, and everything else would sort of take over. It is plug and play, so you can swap out various components accordingly, but that's totally up to your organization and how things work with regards to cataloging. I'm going to stop there. So I've taken you through the metadata standard. I've taken you through the API standard, taken you through the GDC. I've talked to you a little bit about workflows and tooling. I hope this was useful, and I hope this can generate some questions and discussions and comments. So I'm going to stop there. I thank everybody for their time.
Thank you, Tom. This was an excellent presentation and very, very informative. I think there was a question from Morten. Maybe Morten, you can ask it yourself.
Yeah, can you hear me?
Oh, yes, I can hear you, yeah.
Yeah, good. Regarding the discovery metadata, I was wondering if you could just send it with a message, the MQTT. You said that you're downloading it after you get the message, basically, right?
Right. In theory, somebody could do that, where they can just instead of sending a notification with a link to a message, in theory you could just send the message in line. In WIS2, we're choosing not to do that. We're choosing to send the message and then providing a link to the link to the message, and that's an architecture decision in WIS2. But in theory, you can just send the discovery metadata itself, and then that would prevent an extra HTTP download inside your system.
Okay, so the message that you mentioned, the message and notification. Is there a difference between that?
It's the same thing.
Okay, so it's both MQTT.
Yes. So the protocol for the event-driven is all MQTT, and the notifications are sent using a GeoJSON payload, which is the notification message.
Okay, so then you notify about data
or metadata.
Okay. Yeah.
So you would subscribe to a topic. Actually, let me see if I can open up a link to the global broker. Let me just share up my screen. Share. Are folks able to see my screen again? Okay. So here's the Medio France global broker. So if I connect to the global broker through a very generic MQTT client, it should be working. Let me try this one. And of course it's not. This is the law of the demo. Okay. So here we could see subscribe to the global broker. And we could see here the different topics. If I see this metadata topic, okay, this is Korea, for example. So in this example, they are doing exactly what you're saying. They are sending the actual discovery metadata, which is not correct. So we'll need to get in touch with them accordingly. I'm just looking for a topic which has metadata messages. Metadata, or Okay, so this is from DWD. So in this example, DWD is publishing discovery metadata. The global catalog is subscribed to the global broker, looking for just the metadata topic, the metadata category.
Okay.
And then here we would see this notification message. And the notification message is pointing to the metadata record, which is exactly here in this link, in this canonical link. And then from this point in time, then that is where the Global Discovery Catalog is reading the message and then pulling that HTTP link from a cache, which would be this canonical link. So it is an extra hop. Yeah. But that doesn't stop your activity. I'll be honest, I don't know too much about your activity, but that doesn't stop any other activity from making an architectural update the way you described with regards to just sending the discovery metadata in the actual message. It's
but
just,
if you want to get data from us, you want it to be separated, right, in their own topics, or?
Yes, I mean, if we wanted to get data from your activities, you would stand up a broker, a global, well, your broker, and you would implement the topic hierarchy, and we would be subscribed to that, and then we would be looking for data or metadata. But basically, we prescribe the notification message as the single payload type because we want the brokers we don't want the brokers to be checking what type of message it is. We just want the brokers to be checking for this one notification message, which will always have a canonical link, which is the resource, and then everything is opaque. Or you know, it's very clear from that perspective. So we don't want too much logic in the broker that way to be able to do things accordingly.
Okay. Okay, thanks.
Okay. Other questions or comments?
I have one regarding the WIS 2.0. We talked about metadata APIs and search APIs. Is there a plan to have a user interface for the catalog as well?
That's a good question. The OGC API record standard allows for HTML. So in theory, you can have a web interface to the API by simply providing the catalog. So that's possible in theory. In WIS2 itself, I believe Korea, KMA, will be providing a gateway or web application that is talking to a catalog. So they're working on a search interface to be able to do that.
The reason I ask is that with the FEMDI project, one of the components is the user interface, which would be built on top of these OGC API records for the European data. So I was wondering if there's similar developments happening elsewhere.
Yeah, definitely Korea. And I would probably talk to Met Norway. Maybe not specifically for the WIS2 catalog, but they have done metadata interfaces. So someone like Oystein is always a good contact to have a discussion with regards to that. I mean, there's one thing to provide the interface, and then there's also the user experience. And web application user interfaces are hard. So they're a lot of work. So whatever you can glean from the communities out there to make it easier on you would be recommended.
Yeah, thanks. And Morten, the previous speaker, is actually the one who is the catalog person in Met Norway.
Okay, nice. Excellent. Any questions on the actual? I'm not sure if. Okay, any questions on the actual technologies, or like what are your plans for cataloging and metadata in your applications in your project?
That's a good question and quite a broad question. So this FEMDI meeting that we now have is providing like shared components for all the European meteorological institutes, and one would be the catalog, and one is the message broker, probably the same one that Meteor France is offering, and then API gateway, which is something that doesn't exist in WIS 2.0, but there's going to be one for the European users, and that this project is partly funded also by European Union, and they have a strong desire to have these high value data sets, which meteorology is part of, to be available for broader audience. So those three components are developed in this FEMDI context, but then in this same project, Rodeo project, there are work packages for different data types, like ESO, which is supplemental observations from the European weather services, and Morten is actually lead for that work package. And then there's multiple other work packages, one for warnings, and then radar, other stuff as well. But in this FEMDI context, we are now planning these three major components, and there's a company, CGI company, and that is contracted to implement some of these things. Nice. And they are here also now learning about these components and also what is happening in WIS 2.0.
Mm-hmm. Yeah, I would say the WIS 2 specific things are, I mean, most of what I've described is basically the OGC standards. And then the WIS 2 parts on top are obviously very specific to WIS 2, but they try not to touch, they try not to put too much overhead on top of the OGC things. And that's going to give us a very broad interoperability. Like in WCMP2, we only have one additional element on top of OGC API records. So that's, I think that's going to work out well, because we're not designing something too specific for WMO, and it allows for reuse as much as possible through similar activities.
Yeah, and a similar approach also in FEMDI, that it's compatible with WIS 2.0, and it just adds some things on top of it, like this API gateway. And when it comes to message broker and the catalog, it leans quite heavily on WIS 2.0. Although in the catalog we do have to implement the actual user interface. I know that it offers the HTML version, which is very nice for the developers, but maybe not for the general public. So we may want to or may need to develop user interface on top of that API.
Yeah, definitely. There's something to be said around the user experience. That's for sure.
Yeah.
I can circulate the presentation.
Yeah.
And happy to take any questions offline or any other discussions as well.
Hello?
Yes.
Can I ask a question?
Yeah, go ahead, Martin. Yeah.
Yeah, so I just looked up the OGC API records standard, and it says that it's still in draft. That's true?
That's true. That's true. I mean, the goal is for quarter three of this year, to have that to the architecture board of OGC. We've done a lot of work in the last, I would say, 2 months to harden the specification. It is very close. I mean, what you see there now will probably end up being the very 95% of the core specification, but it does need to cross the finish line and get certified as a 1.0, which will let us use that accordingly in WIS2. So we're pushing on that side of the house as well. So I'm the co-chair of the OGC API Records Standards Working Group and co-editor of the actual specification. So we're pushing on that side of the house to make it final.
Okay.
Yeah.
Thanks.
Are there any other questions? It looks like that not at this moment. So thank you, Tom, very much for this presentation. I'm sure that this was quite helpful for all of us.
Anytime. I'll circulate the presentation through email, and please don't hesitate to get in touch if you have any other further questions, comments, or suggestions. So look forward to working with you.
Okay, thank you.
Have a nice day. Have a good week. Thank you.
Thank you very much.
Thank you.